Hello, my name is Alex Tapscott, and I'm delighted to be here with you today remotely, delivering this closing keynote remark at Blockchain Live. This is a very exciting time in human history, and I think that's why we're all gathered here today. And that's because the world is entering into a second digital age. So the first digital age was marked by the rise, of course, of the computer, the PC, the internet, the smartphone, and the mobile web. And now we're entering into this period where technology is ubiquitous. It's part and parcel of our daily lives, of our society, of our business, of basically every industry. And there are lots of these new technologies that people talk about: artificial intelligence, of course, and machine learning, technology in our bodies, robotics. But there's one technology I think that has excited us all, and that, of course, is the technology behind cryptocurrencies like Bitcoin, and it's, of course, called the blockchain. It's our view, based on years of research, that blockchain technology represents nothing short of the second era of the internet. And as a result, it's going to have as great, if not a greater impact on our world as the first era of the internet. So let me explain what I mean by that, and then we'll get into some details and some of the exciting opportunities here. So the first era of the internet was the internet of information. When you send something online, you're not sending an original, unique thing. You're sending a copy, and you're retaining an original. Now, for lots of kinds of information, that's just fine. In fact, it's one of the big benefits of the internet. When you send an email to one person, you can send the same email to everyone else. When you host a website, anyone can access it. If you put an entry into Wikipedia, it's available for all to see. So it's like the internet gave us each our own little printing press for information, and overall it's had a very good and positive impact on the world. Except when it comes to things that have value, assets, like money, being able to send a copy digitally is, of course, a terrible idea. So if you owe someone money, it's important that when you send it to them, that they know they've got the only version, and you can't send a copy to someone else. And that's true not just of money, but of basically every single asset in the economy: stocks, bonds, scientific data, votes in an election, digital identities. These are assets where sending a copy is actually a terrible idea. And this, of course, is the double spend problem that computer scientists have been trying to figure out for the better part of a couple of decades. How do you ensure that when you move something digitally using the internet, that you aren't leaving behind a trail of breadcrumbs, that you don't have another version of it that you could send to someone else? And because this was such a difficult problem to solve, even though that first era of the internet was supposed to be a decentralized network that empowered and democratized access to goods and resources, it actually kind of had the opposite effect, in that power and money was concentrated in the hands of a few large digital conglomerates. And these intermediaries and middlemen are the successors to a long line of former middlemen, banks and governments and large corporations that sit in the center of transactions and perform all these important roles. They establish identity, they create trust, they do the business logic, record keeping, transacting, contracting, all the things that basically makes commerce work. And overall, these intermediaries have done an okay job, but of course they've got some pretty big limitations. They're centralized, which makes them vulnerable to hacking or to attack. They exclude big parts of the population. You know, there's more than 1 billion people who don't have access to financial services or identity, a way to prove who they are. They add cost and friction to the economy, making it take days or weeks to move value between individuals or corporations around the world. And of course, the most problematic aspect is that they capture data. And this is problematic because we create it, you, me, and everyone around you, but we can't use that data to organize our affairs, and we can't monetize it. And worst of all, it might be used to compromise our privacy in some way. So these intermediaries, you could argue, have actually kind of captured more of the value of the internet that I think a lot of people were expecting. So what if the internet were entering into a new era? From an internet of information to an internet of value, based on this technology called the blockchain. So for the first time in human history, individuals need not know nor trust each other or rely on an intermediary to establish trust and to do business and to create value. Instead of an intermediary establishing trust, it's done through a combination of mass collaboration, consensus, and clever code, which is why we call blockchain the trust protocol. Now, blockchain technology is a sort of amorphous term, and it's used to describe lots of different things. And a helpful metaphor that I like to use is this thing called the parable of the elephant. So it's an old story about a bunch of men wearing blindfolds standing around an elephant. And one person's touching the leg and they say, oh, you know, this is the bark of a tree. Another one's touching the ear and says, well, this is a palm frond. Another one is holding the tail and says this is a snake. It's the same thing with blockchain technology. It represents different things to different people. And I think this is particularly true when we're talking about crypto assets, which of course is one aspect of blockchain technology, but I think one that's stoked and provoked lots of excitement and also, I think, a little bit of confusion. So for the most recent edition of Blockchain Revolution, we decided to demystify the world of crypto assets and to break it down into basically 7 different types. So it turns out that cryptocurrencies, the word that we use as sort of a shorthand to describe all these assets, are actually just one of 7 different types. So Bitcoin, Dash, Ripple, things like Monero, Zcash, these are cryptocurrencies. They're designed to be a medium of exchange, a store of value, a unit of account, the things that we traditionally associate with currencies. The second category are these protocol tokens, these platforms. And of course, the best known one of these platforms is Ethereum, but there are others, things like Neo and Cosmos and Polkadot and Tezos and Icon and Aeon and all of these other ones. And these are not designed necessarily to be currencies in the traditional sense. They're basically platforms, operating systems that allow you to run smart contracts or distributed applications, which could potentially disintermediate all the traditional third parties from many different industries. And as a result, they've garnered a lot of attention and captured a lot more value over the past few years of the overall ecosystem. Built on top of these platforms are application tokens, so-called utility tokens, which are basically native digital assets that work inside of an application ecosystem. So one of the more popular and I think more interesting use cases is in distributed file storage or distributed computing, what companies and projects like Filecoin and Golem do. These tokens incentivize people to commit resources to a decentralized economy and in exchange get access to services or get access to compute power. And I think if you look at the activity in the ecosystem over the past year and a half or so, a lot of the new capital that's been raised has been for these so-called utility tokens. And I think there are definitely lots of applications where that makes sense, where a coin or a token that's unique to an application would have a lot of utility. But I think for a lot of these projects, what they were really trying to do was to raise money to fund a new business. And in essence, I think some of them really more resembled securities than something else. And that's where we get to category number 4, security tokens or securities tokens. So basically, if you look at the whole world of assets, the $200 billion that crypto assets are worth are a pretty small part of an overall economy. Take the stock market, for example. I'm in Toronto, Canada. Our stock market's about $2 trillion in size. The US stock market, about $20 trillion. The whole global stock market is over $100 trillion in size. And these assets, though they may have a digital front layer, sort of the user interface, what's actually happening behind the scenes in these asset classes is based on technology that can be decades old, which is why when you want to buy or sell a security on the New York Stock Exchange or the London Stock Exchange, you're actually buying and settling T+3 or T+2. So it basically means it takes 2 days for the asset to actually move from the custody of one person to the custody of another. The clearing, the messaging may happen instantly, but the actual process takes days, which is really odd. You know, we talk about T+3 for stock and bond settlement. Nobody ever talks about T+3 for emails or instant messages. So certain kinds of information flows quickly, while with value, it can take time. There's no reason why every single financial asset in the world cannot leverage or use this underlying technology. And if you think about it, we are basically on the brink of one of the biggest transformations of wealth in human history, where whole asset classes that are built on hundreds of years of iteration and innovation are about to move from analog to digital. And that's very exciting. Category number 5, natural asset tokens. So these are basically digital assets that represent a physical asset in the real world. So a barrel of oil, a bar of gold, a unit in a building, something physical and tangible. So there's a little less utility here than there is with strictly paper-based, contract-based assets like stocks. Because of course, in the end, someone still needs to actually deliver a physical good or deliver that barrel of oil. But we can automate and simplify the clearing and settlement function of all those assets and maybe even open up new kinds of asset classes, like say carbon or water or air, these sort of captive assets that have remained basically outside of market-based systems. Number 6, which are crypto collectibles or so-called non-fungible tokens, are a pretty fun one as well. So the most popular use case, I think, for these is a thing called CryptoKitties, which are basically unique digital collectible cats that you can buy, you can breed, you can raise, and you can sell and trade to other people. And what's fascinating about this is that people are willing to spend lots of money on these kinds of assets. I mean, why would you spend $100, $10,000, $100,000 on basically what's a few lines of code and an image of a cat? Well, the reason is because you trust, you know that when you own that CryptoKitty, it's the only one of its kind. So CryptoKitties are fun and silly, but fun and silly things are important. And this principle can be applied to basically any other kind of collectible asset, both virtual assets, so you can think about in-game purchases and video game ecosystems, maybe even the creation of the so-called metaverse, where you can move digital assets between games without them being tied to individual companies or individual platforms. You can think about artwork. You know, there's a $60 billion a year marketplace for fine art in the world, and we can use this technology to basically move and store and trade title and ownership to art and maybe imbue it with some intelligence. So that's also a very fascinating use case. And of course, the final one are the so-called stable coins and crypto fiat currencies. You know, stablecoin is this sort of holy grail. People are looking for a way to create stability in crypto assets so that when you buy something for $1, the merchant knows it's going to be $1 the next day. Some use cases there are kind of interesting. I think the more interesting use case is for the crypto fiat currencies. These are the assets that are issued by governments. Now, of course, the only one we've really seen so far is the petro, and by all accounts, this is Venezuela's attempt at a crypto fiat. It's not widely used and may even be fraudulent, so I wouldn't use that as a use case. But I do think that there are opportunities for governments, if implemented correctly, to use this technology to create currencies that clear and settle transactions faster, that broaden democratization of financial services, and make banks and governments more effective in delivering monetary policy. So that's 7 types of crypto assets. And crypto assets are one subtype of blockchain technology. And it turns out that this financial architecture is going to basically transform the way that banking and stock exchanges and other kinds of industries work, and that's only one small fraction. Look beyond that, and there are actually a number of new and exciting business models that we can enable with blockchain technology. We can create new means to connect buyers and sellers into a true sharing economy where people who are actually committing resources and adding value get to participate in the value. We can create new models for monetizing content where artists get paid fairly and get paid first for the content they create rather than get paid last, if at all, which is now how it works today. And of course, we can change the way we think about identity. So I started by describing how intermediaries have captured a lot of resources from this first digital age. And that's because they own a part of our identity. But our identity isn't owned just by one intermediary, it's actually fragmented and spread all around the world. So it turns out there's a virtual you out there just like there's a virtual me, except the virtual me is not owned by me, it's owned by Facebook and Uber and Google and Netflix, my bank and my government. And it turns out that the virtual me knows me better than I know me. And of course, that's problematic for reasons that I've stated. So instead of this digital feudalism, where basically we work the land and we provide the resource, data in this case, in exchange for access to a few free services, what if we took a citizen-centric view of identity, where individuals had sovereignty of their own self, where they had a little black box where they could keep everything about themselves, and you or I would decide whether or not our information was shared with anyone we interacted with online. What a concept. So you want to buy something on the internet, it's not actually necessary that the merchant knows exactly who you are. You know, if you go down to the corner store to buy the newspaper, you still do that, and a can of Coke, the guy who works there is not going to ask you for your driver's license. He's not going to know where you live unless he wants to take you out on a date, because all you need is the cash, you know? Cash is a bearer instrument. Once you hand it to him, he has it and you don't. The same thing should apply for purchases online. There are, of course, other kinds of use cases where you may want to share more data about yourself and where you may be required to. Let's say you're accessing a loan from a bank to buy a house or you're buying an insurance policy. The difference, of course, is that your data isn't owned by Equifax. They're not pulling it from some third party. It's up to you to provide informed consent. So that is 3 different potential business cases or business models that can be enabled by blockchain. New sharing economy models, digital data that is centered around the individual user, and of course, new models for creating content. Now, of course, there are reasons why blockchain may not succeed, reasons why it may not reach its potential. In fact, there are so many that we keep coming back to this concept of so-called showstoppers, reasons that blockchain might not reach their potential. And there are a few of them. Is the technology ready for prime time? Can it scale? CryptoKitties, the example I gave, is a brilliant use case, but it also helped to clog up the Ethereum network temporarily. So even modest applications of blockchain can put strains on the underlying architecture. Will governments react in a positive or negative way to this technology? How will incumbents respond? How will banks react to a technology which could potentially disintermediate them? Bigger social questions. What does this mean for the labor market? If we're talking about taking people out of the center, we're inevitably talking about jobs. And of course, we need to create societal responses to these questions. So for every single one of these, you have to sort of ask yourself, is this a reason that blockchain is a bad idea, why we shouldn't be pursuing it? And for that matter, shouldn't be pursuing artificial intelligence or any of these other technologies? Or is it an implementation challenge that we should all try to overcome? Because the opportunity here to rewrite the power grid and the old order of economic affairs for the better is here. And it's basically our opportunity, our personal leadership opportunity to step up. So I started with the parable of the elephant. I'm going to end with the parable of chess. So there's an old story about the invention of the game of chess. And it basically goes something like this. The king is so pleased with this amazing invention that he offers the creator anything in the land, whatever his heart desires, as a reward. And the inventor, who's quite clever, says with fake modesty, "Oh, sire, I am but a humble man. I am a humble servant of His Majesty. All I want is some rice to feed my family. But I want you to give it to me in this way. 1 grain on the first piece of the chessboard, 2 grains on the second piece of the chessboard, 4 grains on the third, and so on and so forth." And the king, who I gather is a great leader, but not really like a math guy, basically says, "Yeah, sure, whatever, a modest request from a modest man, says your wish is granted." Of course, 4 grains becomes 8, becomes 16, becomes 32, becomes 64, and so on and so forth. So by halfway through the chessboard, it's enough rice that the kingdom can't even produce it. And by the end of the chessboard, it's enough rice to cover the whole planet in 6 feet of rice. So I think that's kind of where we're at, right? The first digital age has transformed the world in really amazing ways. I think in the 1947-48 period, right as this was dawning, we were sort of on the first piece of the chessboard. Now, 70 years later, we're right in the middle. The world is virtually unrecognizable. But think how much it's going to change in the next 70 years. So all I can say is, don't be afraid and join the blockchain revolution. Thank you very much for having me, and enjoy the rest of the conference. Thanks.